Hi, welcome back to WOW TV. Today's episode is our lesson on Bubble-Ology. This is a great lesson to do outdoors. We actually only schedule it here for our WOW program in the fall and the spring, and it's best for younger students, but good teachers know with anything else you can adapt it for older students as well. If you have a place in your building, maybe a multi-purpose room or a gym, where it doesn't matter if you make a mess and get the floors a little wet, by all means do this any time of the year. But we like to schedule it and take the kids outside for it. In this lesson, we talk a little bit about surface tension and water molecules, but it's one of those lessons that sparks an interest and makes students realize that they're having fun and doing science. Surface tension is the bond that holds water molecules together. And like all of our lessons, you're going to get a list of facts that you can use to review with your students if you want to, or you can just jump into the activities. We want the students to learn a little bit about the surface tension, and that when combining water with soap or a detergent, it becomes a little bit elastic. And that springy quality is what makes bubbles possible. As we know, water, like all substances, is made of molecules that are too small to see. So bring in a little of that with this lesson and talk to your students about molecules, about hydrogen atoms and oxygen atoms. We have a picture here that we include in our packet so you can show the students the visual. But what I like about these pictures is it shows them attached together. And this is a way to bring in a little bit about cohesion and about these molecules being sticky and hugging each other and sticking together. All right, let's go into our activities. The first thing that we do with any activity is ask students what they already know. What do they know about bubbles? When have they played with bubbles? Listen to a few of the stories. Then ask the students what shape they normally see bubbles in. For our first demonstration, we're going to fill a glass of water as high as we can without letting it spill over. So I have this beaker here. Now this is one of those lessons, do what I say, not as I do. I would recommend you not use a beaker with a spout because we don't want it to spill over, and unfortunately it does begin to spill sometimes when I get it too close to the edge of that spout. But anyway, I use this moment to show the students that I'm filling it up as much as I possibly can. So I'm going to use my dropper so the students know I'm filling it as much as I can. I'm going to throw some science words in. They all know what paper clips are. We're going to ask them to predict or estimate how many paper clips I can put in the beaker of water before it overflows. Then ask them to count along. Now I'm going to be really honest with you, and I'm going to tell you that I never get far enough to see how many paper clips I can actually get in here without it overflowing, because the oohing and awing makes me lose count anyway. Bottom line is, they're only going to expect a couple. I think I've gotten up to 35 before. But this is the time to have them observe what is happening, that maybe they'll be able to see the dome effect at the top of the water. But we want to keep going as long as you want. And talk to them about the surface of the water kind of bulging. That surface tension, which stops it from overflowing. But as we know, at some point in time, there's going to be too many paper clips added to the cup. The surface tension will be broken and it will allow the water to spill over. Okay, let's move to our second activity. Let me carefully get this out of the way. And for this one, we're going to need a piece of wax paper. And our dropper again. You may need the students to come up a little bit closer. But what I'm doing on the wax paper is putting different size beads of water. We want them to notice the shape and the shape that it's always in despite the size. And we also want to again talk about that dome effect. Another opportunity to talk about the water molecules sticking together. They attach themselves to one another. At this point, bring in some other liquids. Do a couple of drops of cooking oil or rubbing alcohol. Have the students look for similarities and differences. Do those molecules stick together the way the water molecules do? Reference back to our picture here of those molecules tightly packed together. Compare and contrast all of those liquids. What would happen then, I asked the students, if we tried to separate the droplet? So take a dry toothpick, a clean one, and see if you can ruin any of these water beads. We can't. They are stuck together. Now I want you to take a little bit of dish soap, your toothpick again, and take just a little bit of soap on the end. And I hope that you can see what's happening here. It is breaking it up. And it has taken apart those water molecules that were so nicely stacked together. Soap decreases the water's surface tension and causing it to spread out. And when soap is added to the water, the molecules of the soap spread over the water and break that surface tension. At this point in time, we want the students to now get involved. Let me get this wet wax paper out of the way. Each student is going to need a dropper, some water, and a penny. I might recommend the teacher doing this activity first, just so the students can see the result and then letting them try. Totally up to you. If you have them come up to watch, obviously you want to make sure that they're not moving the table at all. And then as they go back, maybe you want to have 4 or 5 at a time trying it and doing it in other stations. But we're going to ask the students to predict how many drops of water will fit on the penny without spilling. So you may want maybe flatter dishes with water or extra beakers, and then each student needs a dropper. So have them predict that number. Have them count as you do this. And again, we can talk about that dome effect. We can talk about the surface tension. We can talk about the water molecules holding on to each other and having even kind of a sticky effect. So they're going to be oohing and awing at this point again because it's gone way past their prediction. And again, we can see that dome. And if you want to keep going to see how much more, and if not, there we go. Then have the students try it themselves. Before we move on to the next activity, which will actually include the students blowing bubbles, is a good time to go over the safety rules. Remind them not to blow the bubbles into each other's face or eyes. Remind them not to get any of the solution on their hands and then touch their eyes. And we know that they're going to take those bubble wands and swing them around. That's how you get a good effect. So just talk to them about space between each other before they start doing that. If you have just regular bubbles, even the small bottles that we all get at the store, have them blow a couple of bubbles with those round wands to remind themselves of the shape and size of bubbles that they normally see. Let me show you a worksheet that you're going to receive in our packet. The first column of the worksheet shows the 6 different stations that you're going to have set up, and at each station you're going to have a different shape wand. My assistant put this together for us so we can see the different wands that we're going to be using. There's a flower wand, a triangle, a multi-wand, the star, the square, and the key. At each of the 6 stations, I would have 2 or 3 of these wands. The next column has the students predict what shape bubble they think that wand will create. I would have the students fill in this whole column together at the same time. Now let's go back and talk about the fact that we are doing this outside. Clipboards are a really helpful item to have. Also make sure that your students have their name on their paper because you might want to use this later. They're going to circle the shape that they think the bubble will be when they use that different shape wand. So I would have them make all 6 predictions as they're sitting there on the ground with their clipboards. Then, this is the part that gets a little confusing for students the first time, but there's 6 stations and I guarantee you they're going to get it. Divide your class into 6 small groups. and assign each one a station. So whichever group you want to be station 1, send them over to where the flower wands are and have them wait. Group 2 is going to go to station 2. If you're using our kit, we've already included station cards. Group 3 is going to go to station 3. Group 4 is going to go to station 4, and so on. At each station, have a small flat dish to hold the bubble solution, maybe even a pie plate. We'll tell you what's needed to create the bubble solution and how much the measurements are. And I'm telling you, a little bit goes a long way. But pour some of that in there at each station. When you tell the students that it's their turn to start working, to start experimenting, they're going to pick up that shaped wand, put it in the solution, blow their bubbles, wave it around. And what we want them to pay attention to is the shape of the bubble and the size. Give them a minute or so at that station, have them go back to their worksheet. If they were at station 5, they had the square wand. Maybe they predicted it was going to be in a square shape, so they circled that one. They move to the next column. They're going to draw a picture of the bubble shape they now saw, and then they're going to circle the size. Was it a small, medium, or large bubble that they created? After all of the students have filled that out, remind them of the next number station they're to go to. So those that just came back from station 5 need to go to station 6. Get everybody set to where they are, let them experiment with a different shaped wand, and then come back and fill that out. If there's time at the end of all of this, a couple of different things that we've tried is to bring out a piece of poster board, take your 6 station bubble trays, add a lot of food coloring to each one, and have the students blow bubbles towards that poster board. If there's enough coloring, they're going to make you some great bubble art for you to hang in your classroom. If you decide to do this activity with older students, we've included an activity sheet at the back for a small competition. The students can work in teams and make a prediction of how large of a bubble they can create. We suggest that each group get 3 attempts, and then they measure that bubble. If they take a wet plastic ruler and put it through the bubble, a dry one will pop it, but if they put a wet one through the bubble, they'll be able to measure the height of it, and they can carefully use tape measures to measure the width of that bubble. So that's one way that you could adjust this for older students. Thanks.